No continents, no seas, no blue skies. Just swirling storms and a horizon that never stops moving. If Earth were a gas giant, the surface we're standing on right now wouldn't even exist. And yet, some form of life could still be thriving above the chaos. But here's the mystery. How? The answer takes us from the upper atmosphere down into a place no human could survive, but where strange alien-like creatures might call home. Imagine standing on what you think is Earth, but you look down, and there's nothing solid under your feet. There's no dirt, no water, not even a rock to stand on. Instead, you're surrounded by an endless expanse of clouds, with powerful winds sweeping across a horizon that never ends. The ground you've always relied on just isn't there. That's what happens when a planet becomes a gas giant. These worlds don't have a hard outer layer like Earth's crust. Instead, they're made mostly of hydrogen and helium, the two lightest elements in the universe. From the top of the atmosphere all the way down, it's gas, getting denser and hotter the deeper you go. Without a solid surface, the whole idea of where you are becomes tricky. If there's nothing to stand on, then where do you live, walk, or build anything at all? On Earth, right now, we're used to layers. Solid ground at the bottom, oceans sitting on top of that, and then an atmosphere above. But gas giants like Jupiter or Saturn flip that idea entirely. They're just atmosphere on atmosphere, thick bands of moving gases layered one over the other. These layers aren't all the same. Near the top, the air is cold and thin. As you descend, the pressure builds. The gases compress until they're so dense they act more like liquid than air. In Jupiter's upper clouds, for example, temperatures can drop to far below freezing. Go a little deeper, and the pressure climbs to hundreds of times what we experience at sea level. Past that, you eventually reach temperatures that can melt metal. This change happens fast. Every kilometer down means thicker air, more weight pressing on whatever's there, and a dramatic shift in temperature. But let's say humans still wanted to live on a gas giant Earth. Without land, we'd have to think vertically instead of horizontally. One possible answer? Floating habitats. You'd keep them at a height where the air pressure and temperature are still manageable, far from the deadly crush below, but stable enough to survive the constant storms. It might sound like pure science fiction, but scientists have actually studied similar ideas for Venus. NASA once proposed cloud cities, where airships lined with breathable air could float high above the planet's harsh lower atmosphere. Here's the catch: keeping a safe altitude would be everything. Go too low, and the world changes fast. The deeper parts of a gas giant are not just warmer, they are brutal. The pressure would grow so extreme, it could flatten a steel ship in seconds. Past a certain point, no known technology could withstand it. And even if it could, the heat would become overwhelming, cooking anything that tried to descend. That means a gas giant Earth would be divided into zones. A narrow upper band might be the only potentially habitable space, with storms and high winds in constant motion. Anything below that would quickly become an uninhabitable hell, with crushing pressures and temperatures hotter than any desert here. So, the question is, without any ground to land on, and with deadly conditions lurking just below the clouds, how would life manage to survive at all? Would it adapt to the skies, drifting forever in the upper atmosphere? Or would it vanish entirely, leaving a planet of endless storms with no living witness to see them? If Earth turned into a gas giant, would life still find a way to survive, just not in the form we recognize today? Instead of rooting itself in soil or swimming in oceans, it might drift endlessly above, part of a world where the skies are everything. In that case, cloud life wouldn't just be possible, it could be the only option. Picture organisms built for the air, never touching a solid surface because one doesn't exist. They'd need bodies that keep them buoyant, perhaps filled with gases lighter than the air around them, plus features to gather nutrients and stay stable in unpredictable conditions. But surviving up there wouldn't be easy. The upper atmosphere would be in constant motion, with winds able to tear apart anything unprepared. Temperatures would swing from freezing to blisteringly hot depending on altitude, and light levels would change as storms cast shadows that could last for days. Some scientists have imagined what kinds of creatures might make it work. One concept splits them into different roles: massive balloon-like floaters that drift and absorb energy, and faster, more agile hunters that feed on them. If Earth became a gas giant, nothing says it couldn't evolve similar creatures, just adapted to its own specific balance of sunlight, temperature, and chemistry. Right now, life on Earth depends on sunlight passing through a relatively clear atmosphere, powering photosynthesis in plants, which in turn supports everything else. In a gas giant version of Earth, a haze-rich sky could scatter and block a lot of that light. Life here might still use sunlight, just less of it, or turn to other energy sources like chemical reactions between gases rising from deeper layers. Energy could also come from lightning in massive storm systems, which would spark chemical changes in the air and create nutrients for microscopic organisms. Without soil, nutrient cycles would work differently. You might see vast invisible reefs of airborne microbes that trap and recycle organic material, with tiny particles drifting downward from higher layers and others rising up from below. These microbes could coat themselves in protective shells to survive sudden changes in temperature or pressure, then go dormant until conditions improved. Over time, larger organisms might evolve to host whole colonies of these microbes inside them, living in a kind of partnership to share food and protection. If that sounds far-fetched, consider that even on Earth, microbes have been found living several miles above the surface, carried by natural air currents. They can survive in extreme dryness, freezing cold, and high UV radiation. On a gas giant Earth, traits like these wouldn't be unusual. They'd be the baseline for surviving. Could intelligent life form in such an environment? Getting to that point would be tough. High winds and unstable conditions would make it hard to develop structures, tools, or even long-term communities. Communication might rely on sound or chemical signals carried through the air, and memory would have to be adaptive, since landmarks wouldn't last. Still, intelligence could emerge in a different way, focused less on building and more on navigation, cooperation, and survival in a shifting environment. Even without cities or technology, life could still thrive here for millions of years. Microbes could form the backbone of the ecosystem, with larger, jellyfish-like air creatures drifting through the skies, living slow, stable lives in a narrow layer where pressure and temperature are just right. Below them, an alien-looking planet would wait, a place no creature could visit and survive, stretching from a restless cloud sea down into a hidden, crushing heart. A gas giant Earth would erase everything we take for granted: mountains, oceans, and solid ground, but it wouldn't erase the chance for life. It would just reshape it into something unfamiliar, built for floating, drifting, and surviving miles above a crushing lower world. Habitability isn't always about having land or water. It's about whether the right blend of temperature, pressure, and resources exists somewhere in a planet's layers. If the clouds here could sustain life, then maybe similar skies across the universe do too. That means the next living world might not be rocky at all. It could be hidden in the air,